and some of the satellite services also failed at that particular point of time because of the commercial issue, not the technical ones. So people felt that maybe they won't take off. But a few years back now, the LEO communication has become the buzzword again, and uh, till last year, uh, there was a sort of a clear lobby, the Geo lobby and the Geo, I mean, say GEO, because now we might come across the other GIO also, but that means something else. But the geostationary orbit satellites and the non geostationary orbit satellites. So, because people had already invested a lot of money into the geo satellites and the MEOs, they felt that maybe the LEOs should not take off immediately. But then last year, there was a very interesting thing when a conference took place in India. Uh, all people said, yeah, now we can coexist. And I felt at that particular point of time that now it's a matter of months because the satellite, license, all of them had got license for starting their service. But some minor things, clearances had to be done. Now, it so happened that some developments happened in the meantime. Uh, there is one US company which helped, uh, you know, they utilized, you can say, illegal satellite communication in some of the countries which were at war. And that has shaken the confidence of all the stakeholders, including India. And suddenly, the government of India also tightened their norms, and the Ministry of Home Affairs, they have come up with many more, you can say, clearances to be done, many check boxes to be ticked. And this in the process has, of course, uh, delayed the whole thing for the launch of the LEO satellites. Of course, I would also like to mention that in 1980s, the domestic service had started, and it was a lifeline in the country for some regions. Like, for example, the Lakshadweep Islands or the Andaman Islands, they had no other means of communication. And of course, that is the reason why people are enthusiastic, because there are still some unserved areas in the country which need to be covered. And with the LEO, there was hope that things would move faster and broadband services on the satellite network, the LEO networks would happen. But it looks like now it has got a further little, I would say, not a setback, but it has got delayed a bit more. And I hope that, certainly, of course, the priority goes to the security of the country. There's nothing is worth the security of the nation. We understand that. But at the same time, the whole process needs to be speeded up. Now, the experts here will elaborate further on this. This was just the background of what the whole thing is about and what we are going to talk about. Thank you very much. And Anilji, you can take it forward from here. You are on mute.
Thank you, Vimal, for introducing the subject, taking us from the start of 1971 and then uh, moving us through the journey of satellite communication and what issues India has faced and where we are. So, thank you very much for this. And now let us start with the first speaker, Professor Rakesh Mehrotra. Uh, as Professor Rakesh Mehrotra, during the introduction, we said that he is involved in design and development and evolution of satellite communication in India. I request him to touch upon this subject on evolution of satellite communication as a technology in India for 7 minutes. Over to you, Professor Rakesh Mehrotra.
धन्यवाद अनिल जी. नमस्कार
Please
सभी.
open your video also, sir.
Okay, I think it's over.
Yes, sir.
Okay.
Yes, sir. Yes, sir. Yes,
Okay.
sir. Please.
So
Thank you.
my voice is okay.
Yeah, yeah. Your voice is perfectly audible, sir.
Okay, many thanks. So धन्यवाद and namaskar to everybody. Now I will go little bit back of the entire thing where Vimal started. Basically, it's fascinating and it's very interesting technology to do that because it gives a third dimension to the human being, getting into the space. So entire thing started in 1957 when I was, I think I was 2-year-old or 3-year-old, and then 4-year-old at that time. The Sputnik 1 was launched 1957 by the Russians.
राकेश जी अपना फ्रेम ठीक कर लीजिए, आपकी फोटो नहीं आ रही है, जरा फ्रेम ठीक कर लीजिए.
अब आ गई सर? ठीक.
हाँ, आप जरा बड़े हैंडसम लग रहे हैं आप. बिल्कुल स्पुतनिक लॉन्च कर दिया आपने. चलिए आगे चलते हैं.
Many thanks, sir. So now Sputnik was launched, and there was a fierce competition between US and USSR. Americans thought they are left behind, and they wanted to use for the any technology. I was curator of science museums, so Pragati Maidan में जो gate number 1 पे National Science Center है, that was my imagination. I created that. So I've got the history of science and technology background, deep background in that. So in that particular position, what happened? The Americans thought they are left behind. So they started launching. Eisenhower was the president. They started launching. They pumped a lot of money. A lot of innovation happened. And then that is the beginning of the new age. Now, so both invested a lot of work was happened. So over the last 6 decades, so now the things have started and the satellite communication is started somewhere 1970s. Now, the thing is that from 1970 onwards, all the microwave spectrum, which was, I will touch upon all the subjects. Now, all the spectrum, microwave spectrum was not used and there was no need of that one due to its peculiar characteristics for the terrestrial application. So all the spectrum, it was allocated and dedicated for the different satellite applications. And as per the existing that time, the criteria, the protection criteria, मतलब मेरा व्हीकल 1 किलोमीटर चौड़ा है, 5 किलोमीटर दाएं जाता, 5 किलोमीटर बाएं जाता, तो मुझे 10 किलोमीटर की बैंडविड्थ चाहिए. उस हिसाब से वो टेक्नोलॉजी उस समय का प्रोटेक्शन क्राइटेरिया बना गया, and that came in the ITU. Now, over the period, again and again, new spectrums were allocated for the satellite communication. It was not used. But again, what happened when the mobile communication started? They started using and finding out the techniques, how to use it. In that particular position, then there was a conflict. How to do that? Because the incumbent services, one of the satellite services and terrestrial services has to provide the services within the defined limit what they have to set criteria. So now, but again, technology changed. Industry changed the entire technology in using a satellite and communication and sensing and everything. But again, the criterion is the same. So here there is a big problem where the existing criteria and the technology do not match, and it requires a lot of work in ITU for taking care of that. And ITU has done a lot of very good work where Rajesh ji was there for keeping the register, keeping the industry in shape, trying to do that. So that credit goes to them. Now, at that time, 1970, since Anilji wants me to touch upon Agrani. Now, at that time, the GMPCS was the buzzword. It just started where the communication is a private communication which has to be provided and using a satellite. So, in that particular position, in technology, everywhere where the things starts, a lot of money is pumped where they think that it can be used for the military applications. So there was a program of US of the Star Wars. It could not go through because the president got caught in the Watergate scandal. I'm talking 70s, 80s. Now, all of a sudden, the Motorola, it was not a satellite company, it got a contract of $2 billion from Department of Defense under some coveted framework, and from the $2 billion and raised
Rakesh ji, your voice is cracking. Yes. Now I think you switch off your video and
Yeah, please.
you be on the audio itself. I think that will be better. Yeah. Yeah, it is okay, sir. Please go ahead.
Now it's okay. Yeah. So Motorola, they launched the Iridium, and Iridium went all over the world and collected the money. India also spent around $600 million, something like that. I don't remember the exact figure on that. No, it was a military application in public domain, and they wanted to camouflage the entire world. So this is the way they tried to do that. At that time, we thought, well, if we use the geostationary satellite and use the two 12-meter dia unfundable antennas, one for TX, other for RX, in the space, in the geostationary orbit, we will be in a position to use the small handset and communicate with that 0.5 baud power. So then we designed the entire thing. Everything went through. We negotiated to orbital slot through ITU process, and spent around $550 to $600 million on that. Everything went through. I was involved in that. So UR Rao was our advisor. Jai Singh and Narayanan Saab, who was the Padma Shri. Myself, it was a team of 35 persons. We did that. So we were involved in all the exercise to do that. Getting the permission. Garg Saab was the, I think, wireless advisor for some time. So all those activities we did. And we reached to a position where we could launch the satellite. But by the time, and we had the two satellites initially planned. And basically, it has to be used for the telecom application, the GMPCS application against the Iridium, and then used for the broadcasting application, where I had a couple of patents on that. So all these things we did over there. But again, the India had gone for the Pokhran test, and the ban was imposed. We tried to come out of it. We were told we apply through FCC. We declined because the services has to be provided in Asia and Africa. So the project went in the shelf. Nothing happened. Then I lost DTH and all those things. That's a different story altogether. So what I mean to say, in the satellite communication, if you look, any satellite, it's a proprietary technology they use it. They do not tell what frequency bands they are going to use it. They just tell the broad idea. And then, I think IT helps everybody to get the orbital slots and all those things. This happens overall. That's a good process. But the business plan of any satellite system, it goes 50% of that. It comes from the defense applications, because nobody knows what is in the payload, how they are communicating, what is inter-satellite links are there, and all those things are there. So this is a situation what happened. Now coming back to the 6 years back, what Vimalji was talking, the satellite communication, it was at that time, launching cost of, I'm talking 1997, of 1 pound of the payload, it was equivalent to $30,000. So that was very heavy cost on that. Now, what happened after that, the technology of 3D printing came, then there's multiple satellite launches and the LEO, it happened. And then the first satellite, first venture, it took place of the OneWeb. So OneWeb came in that particular position. The OneWeb is the venture of the RA, British, this thing, where UK has the golden share. It's a wonderful system to work it out. It's a practical system. But again, the problem is balance. It says very clearly, OneWeb has formed a proxy board which will look after the interest of 5 I nations. What I mean? It means, we say OneWeb is Indian and all those. I fully agree with that. We have spent $500 million on that. But it has got the golden share of US, in the UK government, and it has got a proxy board which looks after the satellite, the defense payloads of 5 I nations.
Rakesh ji, may I request you to kindly wrap up as early as possible? Thank you.
Okay, I have taken. Okay, so that's the situation where it comes through. So now OneWeb has come, all the LEO satellites have come over there. LEO satellites have got the dual use technologies. And with these dual use technologies, we have to be very, very careful. As far as India is concerned, we have been talking a lot, but unfortunately, till date, we have not made any filing for the Leo satellites. That's one thing. Second thing is that if anybody is trying to give you something free, there is a cost to it. Who is going to pay for it? So there are a couple of issues over there. So I'm just closing it down, as Anilji says, and I will be ready to answer anything. Thank you.
Thank you, Professor Rakesh. And we will be talking more on the panel discussion and in question answer session. And Professor Rakesh has given the interior background, which is not in the public domain, how the technology has developed, what are the interests of various countries, how the geo technology is working in satellite communication, and for dominance of various countries in this particular technology. So kindly keep your questions ready for Professor Rakesh. We will be giving sufficient time to all of you. Now we are coming to Dr. Rajesh Mehrotra. As Dr. Rajesh Mehrotra is basically involved throughout his life in building the satellite communication world over, including India, and presently also he is involved as a consultant in the same field. I request Dr. Rajesh Mehrotra to talk on ITU and SATCOM, which will help us to understand the role of ITU in SATCOM. Over to you, Dr. Rajesh Mehrotra. Sir, you are muted, sir. Please unmute yourself. Yes, sir.
Good evening to everybody. Thank you for giving me this opportunity to talk to you on a subject that is of great importance to India and to the whole world. I thought that pictures speak more than 1,000 words, so I've got a presentation where I will run through very quickly through some of the impressions that I've gathered at the ITU, and I've called my talk as ITU and SATCOM. Now, if you look at this slide, ITU and space services began, or rather the space services began 61 years in 1963, and we have done 61 years of regulation of the satellites. And the first space conference in Geneva in 1963 is where the entire process began. And rest of the details are all here. We have 2,600 satellite networks that are operating. This may include some of those non-geos that I think Vimal was talking about in the beginning. We have 6.2 terahertz of spectrum coordinated and recorded in the ITU's MIFR, Master International Frequency Register. And we have claimed in the ITU that 99.86% of spectrum as a result of the use of the ITU's radio regulations is free of harmful interference. And less than 0.1% of interference is a variation every year. So you can imagine how stable and how well these regulations are. And the ITU, it does provide the right balance across all the three regions of the ITU, which I'm sure all of you are aware of, and giving voice to the governments as well as to the industry in a moment when private sector is boosting up its space activities in a big way, as you can see. Now, this just indicates to you as to what are the coordination requirements. It was a very tedious job to coordinate between, if you can see my cursor, between terrestrial, which has the trans and the receiving stations, the non-geostationary satellites, and the geostationary satellites. The dotted lines indicate the potential of interference that can be caused from one to the other. And these numbers that you see here indicate what kinds of coordinations were required as per the radio regulations to bring about an interference-free scenario. So it was a very complicated, it still is, a process which could be done only through the use of ITU's software. Now, there was a talk by Mr. Vimal Baklu where he talked about the non-geo satellite networks that came into being, or they were proposed in the early or the late 1990s. Now, these systems, they all failed, and for the reason that he explained, not because of the technology, but because of the commerce. Now, the financial feasibility of the new era mega constellations that you see as of today is based on three factors. The improved single satellite performance, you have steerable multi-beam antennas, you have frequency reuse, you have spot beam technology, which is being utilized not only by the GSO satellites, but also by many other non-GSO satellites as well. And then we have the reduced launching and manufacturing costs, which is a very, very big important. The satellites have reduced in size and cost and launching cost. The size of a small washing machine or maybe a cooker is the size of a satellite now. And overall, you also have what is called as the SDMs, the short duration missions. So we had the great leap in satellite launching by a private company very recently, where Vikram 1 was launched. And I'm sure these launch vehicles will give a big boost to the SDMs, which will bring in a whole lot of encouragement to the universities and many other organizations which have space, Earth observation satellites and so on. And then there is obviously an increasing demand for broadband access. Now, there is a history which went into the use of non-geostationary satellites. I have tried to talk about it. I will run through it very quickly because I don't have much time. In 1995, the first non-GSO FSS proposal was made in the Ka band, and all the legacy satellites, in the GSO were all very scared of interference. So a stipulation was introduced in the ITU's radio regulations called 22.2, which said that non-GSOs cannot interfere with GSOs. But the question was how to show that, how to prove that. So in 1997, there was the introduction of a methodology, and also certain non-GSO constellations were showcased, like Teledesic, Global Star, Iridium, and so on, where it was said that if you can meet the EPFD criteria, which was established in the WRC 2000, and the algorithm for that was developed also as per the recommendation S1503, if you meet the criteria of the EPFD limits in the Article 22 of the radio regulations, then you have met the conditions of 22.2. So this was a very important decision. But the point is, how do you validate your EPFD values? So it took 16 years from 2000 to develop those softwares, and by two companies called TransFinite and Agenium. And this particular software is today being utilized by administrations and also by the ITU. But it is wrought with a lot of limitations, problems, and it is still being improved over the years. And coming fast forwarding to the year 2026, this recommendation has undergone 4 changes, and currently it's in 1503-4 because it requires NGSO modeling, improvement in the modeling, and many of the issues still remain unresolved. ITU is not able to give a favorable finding to all the frequency assignments of all these non-GSO satellites, including the ones that Vimal talked about. We are talking about OneWeb, Professor Mehrotra talked about it, and the other Starlink satellites, etc., because ITU is still not giving them the totally favorable finding. They are entered in the MIFR with a caveat, and that caveat is that these will be revisited when there is a better modeling of non-GSOs and so on. So there was a circular letter of the ITU, which is 414, which is talked about here. And then ITU Working Party 4A studies are trying to improve the situation further. There is another issue about space sustainability, And what is important is that in this particular thing, we are talking about sustainability and also how to monitor. And if a satellite organization experiences some interference, how to report and resolve it. So there is what is called as the sustainability gateway. And all you have to do is to go to this QR code, scan it, and then you will be led to a whole lot of data which one can study in spare time and find out. And as you said, you're sharing this on the YouTube. So these two QR codes, one for the sustainability and other for interference reporting. And then I have put a small URL at the bottom, which is a YouTube or a video, which if you can go through, it'll provide you a whole lot of details into how to go about it. And then ITU has also developed a satellite interference report and resolution system, which is called SIRRS. And this also talks about those details if you go on to this URL. Then global pairs, India's 2.3 billion SATCOM market. The emerging Indian SATCOM market, which is expected to reach about $20 billion by 2028, is driven by direct-to-cell communication service introduction according to the KPMG.
Dr. Rajesh Mehrotra, may I request you to kindly wrap up as fast as possible? Thank you.
Okay, then I think I have wrapped up because I have a lot to talk about, but then we will then cover it as an answer to the questions. Thank you very much.
Thank you, Dr. Rajesh Mehrotra, for kind acceptance of my request in the benefit of all the audience. Now I am requesting the most visible face of satellite communication and radio communication in India, Mr. P.K. Garg. And as you know that he was a former wireless advisor, so we'll listen more about how the equitable distribution and a democratic way of utilization of the satellite communication can be possible and what has been done. Over to you, Mr. P.K. Garg, sir.
Thank you, Anilji. And thanks to DCIF for holding this webinar and for giving me this opportunity to share my views on that. I just want to ask, would somebody be able to share my presentation or shall I share it myself?
Ravinder?
PK Garg, sir, share if any difficulty, then we will switch back.
Okay, thank
Okay,
you. Let me try to share it. Let me try to share. And I would like to just make a small amendment. Anil mentioned that I am the current chairman of the Radio Regulation Board. I was with the Radio Regulation Board from 2007 to 2014, and I was the chairman for the year 2013. I completed my tenure, two tenures are 4 years each on RRB in 2014. So just a minor correction on that. I'm trying to present my share the screen as such.
Pavanji, you are on mute.
Just a minute.
No, Pavanji is trying to share his presentation.
Yeah, I'm trying to share that one actually. Can you see my slides?
Yes, sir.
Okay, thank you. Because the subject is quite vast, but I thought that a little bit of history about the satellite communication may not that may be quite okay. The concept of satellite communication started with the Arthur Clarke's theoretical concept, which stated that with 3 satellites in the geostationary satellite orbit, it is possible to cover all places on Earth. So that was in 1945, and that was the beginning of satellite communications concept as such. And 1957, the first Sputnik 1 was launched by Soviet Union. And in 1962, the Telestar was launched by AT&T. That was AT&T's thing in the USA. And it was considered appropriate to have an intergovernmental organization to control and regulate this satellite communication globally. And in 1964, the Intelsat was formed, which is an intergovernmental organization. And 1965, April, the first satellite, it was named as Early Bird and also called Intelsat 1. It was launched by Intelsat. And most of us might be aware that in 2001, the Intelsat has been privatized. Then after 1964 formation of Intelsat, 1971, Intersputnik organization was formed by Soviet Union and many other countries as such. Coming to a spectrum allocation for satellite-based services, Vipinji, you want me to change the presentation mode or?
Yeah, it will become a little bit, bigger, and the side tiles will not be visible. That's all.
Just a minute. Let me see if I can.
The bottom. At the bottom, sir.
Yes, at the bottom, I am seeing. It says.
Little to the left. Little to the
Little
left.
Just a minute.
Right. Please go right, sir. Oh no.
I'm trying to go right.
No, you have reached end.
Yeah. Here, just a minute.
Yeah.
Normal.
On toolbar, you can see.
Pawanji is okay. Let's go ahead because time is too short.
Yeah.
Yeah, I think if you don't, I'm not able to.
Yeah, Pawanji, please go ahead. Please go ahead. Please
Sir, go
continue.
ahead.
So the first allocation of spectrum for the satellite-based services was made by the ITU World Administrative Radio Conference in 1959. Some band in VHF and about 10 megahertz in 2.3 gigahertz band for experiments and research. And then in 1963, extraordinary administrative radio conference, the C band and lower edge of KU band was allocated for fixed satellite services. Then there was a 1971 World Administrative Radio Conference, and where the spectrum bands for the satellite services were further expanded. Ka band was added, and it was the broadcasting satellite service BSS was also added. I'm not touching all the aspects, but I'm touching those concerning the salient aspects of the satellite listing. Then in 1992, the World Administrative Radio Conference had allocated spectrum for GMPCS, Global Mobile Personal Communication Service. And as Mr. Rajesh Mehrotra mentioned, the 1995 WRC had allocated spectrum for non-GSO satellite services. So the additional allocations for various other SATCOM services, they continue at various WRC subsequently. Coming to technological developments, some aspects have been covered by Professor Rakesh Mehrotra and Mr. Rajesh Mehrotra. It started with the C-band long distance fixed satellite services. That is, and then it was followed by the satellite broadcasting in S-band, 2.5 gigahertz for community reception. And subsequently, a fixed satellite service in KU band came up, and which was followed by direct-to-home satellite broadcasting in KU band. And because of the larger requirements and demands on satellite communications, it became necessary to place the satellites more closely, to have their coordination at closer locations, closer separations, and various developments, they made it possible as such. And then, because of need for the larger bandwidths was there, larger data rates, so use of higher bands, Ka band, Q and V bands were allocated by subsequent WRCs, and satellites are being developed, as well as some of them are using the Q and V bands as such. Another development which is there is the high throughput satellites using a cellular pattern and multiple beams through the same satellite. And now it is possible that some satellites are practically there, which have data throughput of 1 terabytes as such. One satellite having 1 terabyte throughput as such. Then the SATCOM have got very large strategic use, Earth exploration, and various other usages as such. Another latest development in satellite communication is the use of Earth station in motion using the FSS bands and FSS satellite services as such. So the Wi-Fi services in aeroplanes, they are being used through the eSIMs, aeromobile eSIMs as such. And latest addition is, of course, the non-GSO or the LEO satellite constellations, which have got lower latency and which can allow larger amount of data with lower power on handsets, etc. So coming to the non-GSO systems, the first allocation was for 1992 GMPCS, of course not for non-GSO, but concept of global personal communication came. Then 1995, Telidesic, Omnispace, ICO, Iridium, etc. Those satellite systems came up as such. Their basic concept was to provide communication facility for global business travelers. But what happened that in between the GSM cellular systems came up, and the international roaming facilities also came up on that. And with the cellular systems having smaller handsets and relatively more economical tariffs as well as handsets, and also the same phone number working globally, the need for SATCOM for the global business travelers reduced significantly. And in between all these operators like Telidesic, Omnispace, ICO, Iridium, etc., they were keeping the whole thing in back burner. They have come up recently once again for different distinct. Now, many non-GSO systems are, they think, mega constellations are there, as mentioned by Vimal ji, as well as Professor Rakesh Mehrotra and Rajesh ji also, like Iridium, Starlink, OneWeb. Now, our Reliance Jio also has indicated their plan for a non-GSO system. That's very good for the country as such. And let me also add that most of the existing satellite operators also, now they are planning to go for multi-orbit systems. That means they will have GSO systems, they will have LEO systems and MEO systems to provide various services as a bouquet of various services as such. And of course, Mr. Rajesh Mehrotra mentioned the issue of space sustainability caused by the large or mega constellations as such. Coming to the national scenario, in 1966, the experimental satellite communication earth station with 14-meter dia was sort of planned in Ahmedabad, the present Space Application Center ISRO, with the UNDP assistance, and it became operational in 1967. the concept of INSAT satellite systems was evolved by Dr. Vikram Sarabhai in the mid 1960s. And in 1970, he presented a strategy paper, formal blueprint for the INSAT system as such. Then 1971 February, the first commercial satellite communication earth station with 30-meter dia, it became operational with Intelsat F2 satellite and this was the earth station of erstwhile Overseas Communication Service, which later became BSNL, and now it is with Tata Communications. In 1976, the satellite instructional television experiment was there for broadcast for community reception. Then 1977 to 79 timeframe, the STEP program, the Satellite Telecom Experiment Project, which was a joint project of ISRO and PNT, the then PNT, using the Franco-German satellite system Symphony that was there. And in 1979, many of us might remember, 7 earth stations, they became operational using the least transponder capacity on Intelsat for connecting remote places, Andaman Nicobar Island, etc., and with the metro hubs, etc. And 1982, the INSAT first satellite, INSAT-1 satellite network became operational. So this was about the situation at the national level as such. And it has been a challenge.
May I request you to kindly wrap up?
Yeah, I have just completed my thing and I'll be willing to answer. I'll be glad to answer any questions. Thank you very much.
So thank you very much. Now, it was so wonderful by all the speakers that if we permit them to speak continuously, they may each take 1 hour each. Saxena sir, I'll come to the question answer session. Please hold on. So we are starting a panel discussion with all the 3 speakers. And on the behalf of all the audience, I'll ask one question from each one of them. And I request them to be answered shortly, within 1 minute, 1.5 minutes. So the first question to Mr. P.K. Garg. Sir, how the satellite communication can grow in India in affordable manner, where people, the provider as well as the user can use it effectively? Pawanji.
Thank you, Anilji, for your very apt question. In India, we need satellite communications to reach our entire population spread all over the country at such remote places, very far off places, etc. And as has been mentioned, the satellite communication at the present, of course, is relatively much costlier. But as we have seen with our cellular technology, cellular systems, that's a proven story or proven fact in India as such. It has come, this affordability comes through volumes, the affordability comes through competition. And to bring about that competition and volumes, the government as the policymaker and the regulator, they have to play the role of facilitator and encourage the growth. I can recall from my own experience in 2003, the group of ministers at that time, they had come out with one, amongst other recommendations, what they said, one of the recommendations was, let there be no impediment in the growth of cellular services. So similar thing we need to have, the government needs to have in the case of satellite communication only. Then only we'll have growth, we'll have volumes, and with volume will come the affordability.
Sir, I hope that what you are talking is being listened by the bureaucracy who is planning the policies as well as the political people who have a big say in designing these things for the common people. Thank you very much, sir. Now, my second question is to Dr. Rajesh Mehrotra. Sir, as you have big experience in ITU, what Indian satellite communication can contribute to the ITU plan globally?
There is a lot. Thank you very much. There is a lot that India can contribute. India is already contributing. As you can see, that we have been asking ITU on many occasions to make sure that there are enough softwares now available to do the interference analysis when there are many mega constellations being introduced. The software at the moment is having a lot of discrepancies. So India is taking up this matter. Secondly, there is a lot of allocation that is being made, or frequency assignments, I should say, being made by many administrations, where the use of 4.4, which is non-interference and non-protection basis assignments are being made, which is maligning the whole waters of satellite communication. And finally, India should make a good showcase for direct-to-device systems, where still there are many issues of 4.4, but we need to identify. MSS has to be given a great fillip in this. We have already demonstrated, there was a demonstration made by, I think, in Marsat some time ago, where they showed that MSS satellite from geostationary level can provide direct-to-device communication, and that is something that can be done. There are other progress. There is a lot of other progress being made, which I could answer if a question is being asked, because I could not cover those slides. Thank you.
Thank you, Dr. Rajesh Mehrotra, and wonderful. We all are looking at India being a big contributor to the satellite communication globally, and India being the biggest market in telecommunication. I think the time has come when we have to be in the forefront. Now, coming to Professor Rakesh Mehrotra, Professor sir, what R&D efforts you are suggesting for taking Indian satellite communication to the heights which Dr. Rajesh and Pawanji was talking?
Well, thank you, Anilji. A lot of areas are there where we can take a lead. For example, the ground to space and space to ground optical links. Those are very interesting area to work it out, and it's going to happen to ease out the spectrum allocation condition. The inter-satellite communication we are talking about, we are working about. There are a lot of projects, couple of projects for it with IIT Delhi, my friends. They are doing that. The launch vehicles we are mastering. That's very good. And then again, the satellites. Well, we have not made any filing so far for the LEOs and LEOs, and that's an area of concern because the space is getting crowded, and then the lower orbit is basically going to be used for the defense applications. The third is that lakhs and lakhs of satellites. So far, it was 10,000 till last year satellites operational. Now is going to a couple of lakhs. In that particular position, the capturing the satellite and space debris will be a major issue to do it, and that's again a very interesting area to work it out. And the next and very important area is there is no space law. If somebody dies in the space, whose property it is, who will bring it, what it will happen. So it's again chalta hai abhi tak, but there is no definite space laws. What's going to happen? So space is the next area for the war, next area for the development, next area of the futuristic plans. What you can do over there. So lots and lots of things are required to be done. Thank you, sir. Is there anything else?
Thank you, Professor. And I think the areas which you have mentioned definitely required R&D efforts. But at the same time, there should be a commitment from government as well as from the private operators to put their money in R&D efforts, which is being demonstrated by various developed countries to come up. Anyway,
Sir,
thank you very much, all of them.
Once again, sir, the problem in India is that we are myopic. We so far have learned the lesson how to use the technology and earn the money. We have not seen the area where we can develop the things and lead the world. And perhaps there, the WPC and others, I've been talking to them, they can take a lot of lead, release a lot of spectrum, rationalize the spectrum which is being wasted at the moment. So I'm not saying anybody else, but again, a lot of things are there. If we do that, we release the new spectrum, initiate the industry to do that, and provide the market. So we have to put the demand ahead of everybody. Look, this is a demand. You develop technology, give it to us. And defense will be one of the major consumers of the space segment. So defense has to come forward. Thank you, sir.
Thank you, Professor. Now we are coming. There are a couple of hands which are there, and they have a lot of anxiety to ask several questions. The first come from Mr. S.D. Saxena. He was the person who led BSNL in the forefront in implementation of satellite communication as Director of Finance. Uh, Saxena, sir.
Thank you very much, Anil, and I must compliment you for. Am I audible? Hello?
Yeah, you are audible, sir. Please go
Yeah,
ahead.
so thank you very much, Anil, and I must compliment you for organizing this talk. I have one suggestion, and I don't have any question, but suggestion and a comment. The suggestion is that in these webinars, it will be better if we do it individually, because when we split it in 2-3 persons, the focus keeps getting shifted. Because today I found that mostly we talked about the history and how it was done and all that, but we were looking for something more technical. Now, I had the privilege of working in INSAT when the satellite system was launched, and the concerned DDG was Mr. Rawal. And there were two great people called Brijesh Singhal and Ramesh Chandra, who did all these Earth stations. So we were doing the Earth stations, 23 Earth stations. Cabinet has approved 23 Earth stations to link with the satellite. And there was a lot of problem. We bought the Japanese equipment. We had none of the hardware, and we installed it. And one more, which we did on our own, I and Brijesh Singhal, we worked out a tricky situation in which we put another additional Earth station in Kulu, because the whole Chandigarh, Punjab area was not being connected by satellite. So these are history. I don't want to go into it. One interesting fact which I wanted to tell is that satellite came out of science fiction. The satellite communication was the birth of science fiction. And Arthur Clarke wrote a science story in which he said that we
May I
should hang
request all those who are not speaking to kindly mute your. Yeah, thank you. Yes, sir.
let me just finish quickly, because I think
Yes,
others
sir.
also have a question to ask. So there was a mirror in the sky. Arthur Clarke calculated that if we hang a mirror in the sky, it will be able to connect Europe to America through across Atlantic. And that's why, the great thing about the physics and people who think about being a physicist, I always feel very privileged to think about it, that just a simple concept changed the world, because the satellite was born out of that article of Arthur Clarke. There are a lot of other people, they claim this and that. Now, the concern which I have is that LEO, which is not a very difficult technology, we are lagging behind. We are buying satellites from every place, and we are not able to launch the satellites. I think it will be done. One last comment which I wanted to make was that the satellite, the first INSAT satellite, which was a unique satellite launch, it had three functionalities. It had communication, it has meteorology, and it has also the Earth mapping system. And this, perhaps you must be knowing and you must be aware of it. The satellite was launched under extreme pressures, because the slot of the orbit, which was given in geostationary slot, was getting lost to Indonesia, and we were not prepared. But then we did an excellent job, and the satellite systems were done. And I remember my colleague very much, Brijen Singhal, who did a great job, who ultimately went to Intelsat. But one more thing which we missed was Inmarsat. Inmarsat gave communication to the ships, and that was actually used. So Anil, you asked the question about the cost. I would like to tell you, I was very humble, but I was very privileged to take up this issue. The armed forces which were in Ladakh, we provided them the Inmarsat transponder, and we didn't charge any money for the calls made by the armed forces. So a lot of things can be said, but I must thank you very much for giving me the opportunity to say some words. Thanks very much, Anil. God bless you.
Thank you very much, sir. Honored. Next person who has asked question is Vimal Vaklu. Vimal, please be short in the question. You are muted, sir. Please
Thank you.
unmute, yeah.
Actually, this question is for Rajesh ji, because satellite sustainability, the space sustainability. One aspect he has talked about the interference. The other one is the dead satellites, because these satellites are dying every 2-3 years. What do you do for that, and what should be the condition for people who launch these satellites, because they are a big danger to the whole world?
Well, everybody is aware that they are a danger. Well, everybody is aware that their lifespan is not very long. what is more important is that there are certain companies which are already finding ways to bring down these satellites, and many companies are talking about that they burn up. So these are the only three methodologies. They either burn up or they are captured and brought down. But this has to be implemented at a rate at which these are being launched. The satellite lifespan is going down. That means the number of launches are increasing, but the manner in which they are being brought down is not matching that. So this is extremely important, and only time will tell. But on your question that what conditions can be provided, when there are no means and there are only burning of the satellite in the atmosphere, this is the only way to do away with that satellite. In the GSO, you have a graveyard orbit, which is 200 kilometers above the GSO. But here, there is no such thing. So these have to be brought down and burnt up or captured. So to put a condition, I don't think it's possible at this point in time when the technology is still developing. Thank you.
No, what I meant to say that the company which launches the satellite, they should have responsibility to the end till the end of life of a satellite, from the launch till end. I think this condition should be put by the ITU so that it becomes their responsibility. They can use an agency for doing the job of bringing them down, but ultimately the primary responsibility should be with the organization which launches it.
This matter is being debated. ITU does not make any rules. ITU only implements the rules made by the countries. So this particular aspect of space sustainability is receiving a lot of attention. But there are no such rules that a launcher has to also take care of its debris. But this is the way things are at this point in time. That is why sustainability is going to be a big problem. And as somebody just said, now we are going to put these data centers in the sky. 1 million data centers are being planned by Elon Musk. So they will be more of a problem. So you can't put these conditions when the geopolitical situation is such. Thank you.
Thank you, Rajesh. Thank you, Vimal. And next question is from Mr. Vipin Tyagi, who is the chairman of the Technology Committee of DCIF also. Vipin.
Thank you very much. I think I have posted the question on the Q&A, but what I'll do is that we have done R&D and we have built our own Earth station. People may not be aware, and it was like Pawami, so it is not like public domain, but it was functioning a few years back. Second one is that the HASP, which is High Altitude Satellite Platform, these are getting strategically very important now. These are
Mathur sir, I'll come back to you, sir. Yeah, please go ahead, Vipin.
Yeah, these satellites are actually, you can call them pseudo-satellite because they are below the LEO, and they are very important for the various purposes of controlling, like you can have the control of these low-flying unidentified or identified objects which are there. Also for local interception. And frequency allocation has happened in the US. And also DRDO has done the trial, but I am not sure whether we have got the allocation of the frequency for the platform. These are going to be very important, in my opinion. So this is one question I had. If anybody had to add, because Mr. Garg has said that there is no HASP as of now. So I think I'm a little concerned that we should be the first one to build one and launch one and then control. Thank you.
Can I attempt an answer?
Yeah, please, sir.
Thank you. HAPS are not satellites. High altitude platform systems. That is the abbreviation. These are platforms. These are terrestrial. Excuse me. These are terrestrial systems which are in the stratospheric area. Satellites only become satellites when they go in space.
I know the debate. It is called pseudo-satellite.
Right. Well,
if you see the abbreviation,
In the ITU's radio regulations, these are termed mostly as terrestrial networks, like the aeronautical mobile. And what is important is that HAPs have been discussed a lot in various WRCs. And allocation has been made. If you look at radio regulations, there are frequency allocations. They were in the upper 30 gigahertz and I think the lower 30 gigahertz also. But nobody has still a proven technology which provides that kind of station keeping of these HAPs in the stratospheric area. So that is why HAPs are still not in the Google people started they started off with something called it was called by, they were putting blimps or balloons in the sky and they were using.
They're known as Google Loon.
No, they were also platforms.
But that did not reach a certain commercial level. I mean, only partially. So things are still in the melting pot in this.
Thank you, sir. Thank you for the reply.
So
Next question is from Udit.
Just make a count.
Vipin, we can take up your question later on in case time permit. Next is Udit Vajpayee. Udit ji.
Yeah, thanks, Anil. Basically, my question is very basic and related to the users. Like how many user base we have in India as of now for the satellite broadband services, and what is the revenue size in India? What is the cost or the price per GB? And when we take off these LEO-based satellite broadband services, what is the expected market size in another 3 to 4 years, and what will be the revenue size? And associated question is, what is the total market size across the globe in fact in the matured economy like US, Europe, and China? And what percentage of the terrestrial network, user base is captured by the LEO-based broadband services?
May I attempt some part of it?
Yes, Professor.
Uditji, the whole thing is that the NEO satellite, it keeps on moving. If you look at the economics, the 2/3 of the world, 2/3 of the globe is ocean. And 80% of the population lies in the 50% of that landmass, means Asia, Africa, and Europe. And most of them, and 80% of that is the poor persons. So if you look at the economics doesn't make much of a sense until unless the defense applications are there. So these satellites what we have been talking about, they are basically for the defense application, and a part of it is coming to us. If somebody is going to give free, there is a cost to it, directly or indirectly. So that's the simple answer to that. Well,
So
we are trying
my
to
question is, like so many foreign companies are interested to launch in India LEO-based services. That shows definitely a commercial angle, and that
There's no,
shows
listen to me, Aditji, there is not much of a commercial angle. They first came by the name of the rural connectivity is not the rural connectivity. It is what they are talking is B2B, not B2C or C2C. So this is the status as on date. Take it from me, there is not much of a market. यार जब 5 रुपए 7 रुपए में 1 gigabit की connectivity मिल रही है, can they match it anytime? In near future, in next 10 years, I think it's very difficult. After that, it may be possible. तो अगर मेरे को 10 रुपए में 1 gigabit की connectivity मिल रही है, 1 gigabit data मिल रहा है, तो मैं उसको 500 रुपए क्यों दूंगा यार? The whole thing is that, और अगर वाकई में आपको करना है, तो you only government of India must put the demand कि these are the rural area 30,000 35,000 villages जहाँ connectivity नहीं है. I will provide this much of money to do that. Let them do it. But again, the whole game is the defense, nothing more than that. That's why they're interested in coming to India. Create cockroach parties in India. Thank you.
Thank you, Professor. But Udit, question is very elaborate. So I request that if we can provide his answer to all his questions through on the email to Udit to you, because time is not there for have a big discussion here. Now the next question is Pawanji. Pawanji, I'm coming to you in case you can supplement Professor Rakesh. Yeah, please.
The recent there was a Space Policy Conference held by the ITU-APT Foundation, 22nd and 23rd July. This aspect was discussed in this thing, and ENY, I think they have made some estimate. Rajesh, I think he had referred to this in his presentation. The EY estimate for India's satellite communication field in India, by 2030, I think their estimate market size is $20 billion. I think if somebody can correct me, this was discussed in the Space Policy Conference on 22nd and 23rd July. And market size, they had estimated about $20 billion by 2030 in India. Thank you.
Thank you, sir. Thank you. Now I'm coming to Mr. N.K. Mathur. Mathur, sir. Sir, please unmute yourself. First of all, please unmute yourself. Yes, sir.
Thank you. My turn has arrived. I wish to ask, I wish to dwell on two fundamental issues, one of which is what to do with so many LEO satellites being launched by private operators and by non-GSO services. One question was that they would interfere with each other and harm each other's services. This question was raised by Vimal Vaklu, and nicely he alluded it to ITU and ITU regulation. My question, the second question which I want to see is the large number of LEO satellites, which will be in thousands and thousands in number, would definitely block considerable sunlight, and sunlight would interfere with not only our life but also about our methods of generation of energy, and I do not know how we are going to tackle that issue. That is, we are going to be short of sunlight for our own life and for our electricity generation, solar electricity generation. So I suppose I do not know who would like to answer this question.
Thank you. Thank you very much, sir. May I request Dr. Rajesh Mehrotra to throw a light on the question which Mathur Saab, I think is a very important question today, that how the space required to be managed in future. Sir.
Yeah, thank you very much. Actually, it is not only thousands of satellites, it's going to run into millions as per the latest plans of SpaceX. The reason which SpaceX is giving, that if you take a surface area at a location of, let's say, 600 kilometers above the Earth's surface and calculate the surface area 4 pi r square, is fairly large. It's so large that it can accommodate these satellites. What it cannot accommodate, in my opinion, is the fact that if there is a debris, the debris moves almost at 7 kilometers a second at that region. That even a small piece of the debris goes and hits any other satellite or any other part of the space system, it's going to literally hit it with the force of a minibus at that situation. So right now, there are no rules. The geopolitical situation will decide. And on top of that, there is India, China, US and other countries who are showing their capabilities to blast satellites into space. India has shown it. These are negative things. I would urge DCIF to make sure that this never happens again in India and also doesn't happen in any other country. So this is where we are at this point in time. Blocking of sunlight, I do not see much possibility of that. It may not block. There is only a danger to the other spacefaring object.
Thank you, Dr. Rajesh. I think it was a wonderful discussion which we all had in the last virtually 1.5 hours. Now we are coming close to this interesting discussion. I know the time is less. We have taken note of Mr. S.D. Saxena's advice that in future such evolving and deep subjects should be taken for more time, maybe one speaker in 1 hour or so. Thank you very much for, let me now request Mr. S.D. Saxena, who has led BSNL in the forefront for implementation of this technology. He was involved sometime in the development of satellite technology also, and he is in the forefront even today at various fora of technology development and implementation. To present a vote of thanks, may I request Mr. S.D. Saxena, sir, to present a vote of thanks today for meeting. Thank you.
Thank you, Anil, for this privilege. And I think you rightly chose Stalwart to speak on the subject. First, the thanks go to Mr. Pawan Garg. Actually, he doesn't deserve the thanks because he owns the DCIS. He was a past president. And so his contribution is very much welcome. And perhaps we forget to remember that he was very much active in the WRC. He was the president, chairman, and was the representative of India in ITU Geneva. So his second home was Geneva. And I thank him very much for the presentation. Rajesh Malhotra Sahab is another good friend, and he did a great job in ITU. And now he's back in India, which is, we must thank him. And he has definitely very deep knowledge of the subject, especially if we have to learn satellite, we must go to Elon Musk now. Anything which you do, unless we talk about Elon Musk, we are not talking about satellite. So thank you, Rajesh, for talking about it. And Professor Rakesh Mehrotra, another great man. Professor, if you have to go somewhere, there is an ad in the television which says, "Where are you?" Sharda University. So, sir, you are in Sharda University, and you are doing a great job, and you presented a very interesting historical aspect and also technical aspect of the system. I must thank Mr. Waklu, who also was giving us a prelogue to the program, and he did input a lot of the facts and figures and his experience. So I must thank all the panelists and Mr. Waklu. And above all, the thanks goes to you, Anil, because you have built in new life into DCIF. God bless you. Keep doing this. And thank you very much. Good evening. Bye-bye.
Thank you. Now, at the last, may I request all participants to please open your camera. And I request Ravinder, our General Secretary, to take a photograph, which we will be posting on DCIF website. Ranganathan, Harsh, Umeshji, please open your cameras. Yes, sir. Please take and then confirm that you have taken the photograph.
Yes, thank you very much. Photograph taken.
Thank you. Thank you, everybody, for joining and continue to join DCIF for such interesting webinars.
We started at 21 members. Today, at finish, we were 23. So it's a great,
Thank you.
Great show. Thank you.
Thank you.
Thank you.
Thank you, everybody.
And,
Bye.
Bimal Chawla ji, our old friend Udit joined today. I am grateful to him.
Thank you.
Thank you very much.
Thank you, everybody.
Thank you.
Thank you.
Have a nice Guru Purnima.
Bye bye.
Thank you.
आज है क्या?
नहीं,
आने
नहीं,
वाली है
29th
29 को
29th.
Okay.
विजय जी आपकी किताब बहुत अच्छी लगी, अगर एक कॉपी और भेज देंगे तो बड़ी मेहरबानी।
धन्यवाद सर, और भेज दूंगा।
बहुत बढ़िया लिखी है। आई विल पे फॉर इट इफ देयर इज अ पब्लिशर।
थैंक यू, धन्यवाद।
Ajay ji, thank you. Lot many friends. Deepak ji, thank you for remaining throughout. Thank you.
Deepak ji, Deepak bhai, thank you. Ajay ji, are you still there?
Ajay ji is there still. Ajay ji on mute, please come.
Can I say something?
Yes,
Yeah,
yes.
Deepak.
First of all, let me congratulate ESIF to organize such a wonderful thing. And second part, which I must say, is for us down the memory lane, which we have spent our time right from provision to the retirement. We always had some interaction about communication of different dimensions, particularly sex life or far like this. Thanks, Naija, for enriching us again to all these things. As rightly, let's discuss time was short for 3 results to complete. So it's better to have one time to get more. With this, thanks again.
Thank you, Deepak. Thank you very much. And thank you everybody again. So let us close the meeting today. Thank you.
Thank you so much. Thank you, sir. Thank you. Bye bye.
Thank you.
Vishal Kumar.